Hey everyone, today we're going to be talking about the Hopper data modeling feature from West Monroe. The goal today will be to generate a new target state data model based on some new requirements in our legacy data warehouse schema. Let's get started. Okay, let's start off by configuring the settings for our data model. We're going to create a new data model, so we'll use this first option. Now we have the option to specify the model name. Let's call it a test model to keep it simple. For the target language, today we're going to be using Databricks SQL as our target, but we also have the option to use Snowflake SQL, Microsoft SQL, or Postgres SQL. In terms of naming convention, we'll keep it simple again and just use snake case. So now we have the option to upload some documents, which are the requirements document, which specifies what the target state should look like, and the upload schema document here, which is what the legacy state data model looks like. Okay, I went ahead and uploaded the documents we need. If we scroll down, we can see that we now have a requirements, which specifies the target data model that we need, which is a daily, weekly, and monthly sales performance by product, region, and channel. We can also see on the right that we have a schema, which is what our legacy schema looks like. We can tell that we have a department table, we have an employee table, and if we scroll all the way down, we can see sales territory alongside sales tax rate tables, etc. So once we're good with this, we can save our settings and we can proceed to generate a data model. Okay, so now we're ready to generate a data model. So we will click this button here and we're going to wait a couple seconds until it actually generates our data model. Okay, our model is now finished generating, so we can now go and look at what our ERD looks like below. What we can see is that we have a top-level fact sales table which contains all of our sales data. Additionally, too, we can see that the target state ERD now has additional dimensions here, such as a product table, a customer table, a salesperson table, a date, region, and channel dimension table as well. Additionally, too, we can see that each of these dimensions has a description of how it relates back to the original facts, and we have all of the field names and data types associated alongside the foreign keys and primary keys of these tables. We can also take a look down here at model feedback. In this box here, we can provide feedback on changing table connections, adding or dropping tables, or structural changes, and we can enter that in below and regenerate the model. For example, if we wanted to include a dimension based on discount, we can include that. So we can say add a table for discounts, and we can send that feedback to the model. So we can see that we have now finished generating our updated model. What we can see in the far right here is that we now have a discount object added to the ERD. We can see that we have the discount ID as the primary key, the description, discount percent, type, start date, end date. So let's assume that that's the information I wanted from the discount. We can now move on to provide even further fine-grained feedback. Okay, now we can go on to actually refine our data model on the field-by-field level. We can see that all of the dimension of fact tables that were produced for the future target state have been included here. And now we can also go down and take a look at the field-by-field level. Let's say, for example, that the discount ID that we wanted to actually be a string. So we can actually change this to be a string type. Foreign key, that's okay. And if we needed to change the description as well, we could do that here. And you can click Process Table Edits, and that will update the ERD below with all of the changes that we just made. This process is representative of West Monroe's human-in-the-loop approach to generative AI, allowing humans to correct and fine-tune model outputs to fit the nuanced needs of our clients' business. Assuming that we're happy with the model, we can now proceed to actually create the STTM. Now that we're ready to go, we can create our STTM here. And we'll try to map legacy fields to the target state fields that we just created. Okay, our source to target mapping finished generating. What it tried to do was map all of our legacy fields from our legacy data model to our target fields in our target data model that we just created on the previous pages. If I scroll down here, we can see that we have all of our fact and dimension tables again, and that they have now been mapped from legacy to target. For example, the fact sales target table and the sales order ID, that is being mapped from the legacy sales order detail table and the sales order ID source column, which is what maps to this target. If we scroll down as well, we can see that other items like the unit price from legacy now maps to net total in target with a transformation of unit price minus unit price discount. we can see that these types of sources and targets and transformations are defined for each table that we defined. We can scroll down even further now and come up with our combined STTM data for all of our tables. Assuming that we're happy with all of this, we can then proceed to create our DDL and DML statements to actually go create these tables and transformations. Now we can click here to create those statements. Okay, now that the DDL and DML have been written, let's take a look. What we can do is we can scroll down and we can see that for each of our tables, which are fact sales and all of the associated dimension tables, we now have both create statements and we have insert statements. Let's take a look first at the create statement. What we can see here is a create table expression written in Spark SQL or Databricks SQL because that's the original setting that we set this project up with. We can also see that in this example, we are using fact underscore sales, which is the fact table, and we can see that all of the columns that were originally defined in the ERD are defined here as well, alongside their corresponding data types. We can also scroll down to the insert statement below. This insert statement is what actually maps these legacy fields to the target table that we just created above, alongside any transformations that we applied earlier. Remember that earlier transformation of unit price minus discounted price? Well, that transformation is captured here, and we're mapping it to the net total field. Okay, the last step here is that once we've approved our DDL and DML statements, we can actually select which artifacts that we want to download. The options here are as follows. We can download the original requirements, the original schema, and then the target source to target mapping, data dictionary, entity relationship diagram / ERD, or the DDL and DML statements. In our case, we're going to want to download them all, so we'll click Download Artifacts. Additionally, too, we can download the Mermaid live code, which will allow us to view our ERD later. And with that, we have completed the West Monroe Hopper Data Modeling Accelerator. Thank you.